University of Warwick astronomers are warning that orbital debris posing a threat to operational satellites is not being monitored closely enough, as they publish a new survey finding that over 75% of the orbital debris they detected could not be matched to known objects in public satellite catalogue. The astronomers are calling for more regular deep surveys of orbital debris at high altitudes to help characterize the resident objects and better determine the risks posed to the active satellites that we rely on for essential services, including communications, weather monitoring and navigation. The research forms part of DebrisWatch, an ongoing collaboration between the University of Warwick and the Defence Science and Technology Laboratory, UK, aiming to provide a fresh take on surveys of the geosynchronous region that have been conducted in the past. The results are reported in the journal Advances in Space Research. The research was part funded by the Science and Technology Facilities Council (STFC), part of UK Research and Innovation, and was supported by the Royal Society. This survey was optimized to search for faint debris, objects that are too small or poorly reflective to be regularly monitored and recorded in publicly available catalogues. The U.S. Strategic Command USSTRATCOM, maintains the most complete public catalogue of space objects, using its Global Space Surveillance Network SSN, comprising over 30 ground-based radars and optical telescopes, alongside 6 satellites in orbit. The SSN is able to monitor high-altitude objects down to roughly 1 meter in diameter. Although certain residents of the geosynchronous region are often referred to as stationary, collisions can still occur with relative velocities of kilometers per second. With this in mind, even small objects could cause a lot of damage to an active satellite. Images from the survey were analyzed using a custom software pipeline designed to pick out candidate debris objects and investigate their brightness over time. The resulting light curves contain a wealth of information about the objects themselves, including their shape, surface properties and attitude, but are also affected by other factors like viewing geometry and atmospheric interference. Far above the outermost layer of the Earth's atmosphere, there are no natural mechanisms like atmospheric drag to induce orbital decay, so debris generated in the vicinity of the geosynchronous region will remain there for a very long time indeed. To help them uncover faint debris, the astronomers made use of the Isaac Newton telescope on the Canary island of La Palma, which has a large 2.54 meters aperture, allowing it to collect photons of light over a large area. They used an optimized strategy to ensure that the sunlight reflecting off of candidate objects would fall within the same pixels of the camera, to increase their chances of being detected. Strips of sky were scanned above, along and below the geostationary belt, where most of the operational geosynchronous satellites reside. The majority of the orbital tracks detected by the astronomers had brightnesses corresponding to roughly 1 meter or less. When the researchers included all their detections, including those above and below 1 meter, over 75% failed to match. Many of the faint, uncatalogued debris appear to be tumbling, showing significant brightness variation across the observation window. These sorts of features can tell us a lot about the perturbative forces acting on residents of the geosynchronous region, but also highlight that we need to be more careful when making assumptions about the properties of these objects. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.